Today we are gonna go through annual cash flow analysis. We will solve lots of examples in order to understand this, how we are gonna do this annual cash flow analysis. We already calculated how can we make this series. We can convert the present value to the uniform cash flow, and future value to again uniform cash flow. It's going to be the same thing. As we go through, we will understand better, and then when we solve the questions, we will excel it. What we are going to see today, the outline, is annual cash flow calculations, then how we are going to analyze if we have 2 or 3 different options. And we are going to apply again the annual cash flow techniques, which is useful lives for equal useful lives, different useful lives, and infinite analysis periods. And these guys here, the spreadsheet, we are not going to use in this class. This is out of our topic. We don't need to use in exam. That's why I'm jump. We are going to consider only just till here. Let's jump directly an example in order to remember the annual cash flow calculations. A student bought $1,000 worth of furniture. What is the equivalent annual cost if it is expected to last 10 years and the interest rate is 7%? Let's jump to solution.
Yes, friends. We are gonna have the first question of the economic classes. We are gonna go through the annual cash flow calculations right now. The first example, it is a student bought a $1,000 worth of furniture. What's the equivalent annual cost if it is expected to last 10 years and the interest rate is 7%? As we know that we are gonna find it first, like we are gonna remember right now how can we convert the annual series with respect to present value. We know that we have a formula which is A is equal to the present worth, and then if we use the table is A over P, right? Then we are gonna make it 7% of interest rate, we know, then for 10 years, right? So if we look at this guy, we are gonna find the annual series, annual cash flow. A is equal to the present right now the student bought for $1,000, so the present value is 1,000. Then A over P, 7% for 10 years. When we look up our tables, it is we are gonna look capital recovery factor, find A given P, which is A over P for 7% and 10 years. It is 0.1424, 0.1424. And that means our A in dollars is gonna be 142.40 cents. Okay, $142.40 is gonna be our annual series. So instead of paying 1,000 right now, the student need to pay every month 142 every year 142.40 for 10 years in order to cover now present value. This question is end here. Question, we are gonna be having the same question, but right now the student again buying for the furniture for $1,000 worth. Then after that he's gonna sell after he's gonna use it for 10 years. Then after that he's gonna sell it for $200 after 10 years. So right now we are gonna see the equivalent annual cost before we are saying like uniform annual cash flow. Right now we are gonna find it equivalent because we bought for, like, the student bought for $1,000, then after that 10 years he sold for $200. So we are gonna find the negative and positive cash flows, and we are gonna find it how much is gonna pay uniformly in annual amount of money. um, for this one we need to again use A is equal to the present value, and A over P, which is converted present value to the annual cash flow, then our interest rate, then the year, minus the future value, whatever we made it, but it's gonna be if we are taking the whatever you've spent is positive, whatever we earn is gonna be negative, so the future money value is gonna be negative. And this one, A over F I and N. And if we write it down in the mathematical form, the present value is gonna be 1000, and A over P, which is I, is again 7%, which is not written here, but we know that is 7% from the previous question, and N is 10 years again, and we are gonna say minus 200 A over F, 7% for 10 years again, and is gonna be A is 1000. Let me see, the for 10 years it was 0.1424, 1424 minus 200 A over F is 0.0724, 0.0724. We are gonna multiply, this one is 4, okay. Then the answer is gonna be $127.92. So we had before $142.40, but if we take into account if we sell it after 10 years, $200, then our equivalent annual cash flow is decreasing to 127.92. This question is done here as well.
Okay, in summary, how we are gonna calculate the annual cash flow calculations if we have equivalent uniform annual cost or calculation or whatever you call is equal to present value. In order to, like, we are gonna multiply by the coefficients, or we are gonna use the mathematical formula from present to annual series cash flow. So it's gonna be, here is gonna be with A, and then minus the future whatever you spend it, and is gonna be A over F IN, which is the coefficient we will multiply, and then when we subtract each other we are gonna have equivalent uniform annual cash flow. And also if we manipulate it, it's gonna be P minus S A over F IN, which is the future to annual cash flow uniform coefficient, plus the present worth multiplied by the interest rate. And also the last formulation, these three formulation is gonna be the same thing. This guy is also given equivalent uniform annual cost is equal to present value minus future value A over P IN plus the future value multiplied by the interest rate is gonna give these three formulation the equivalent uniform annual cash flow. So okay, let's go again, another example.
In our third question, we have an maintenance and repair cost. The first year is $45, the second year is $90, third year $180, fourth year $135, decrease to $135. Then the fifth year is gonna be $225 dollars cost. As we see, there is an ununiform distribution of cost, and then we want to find the annual cash flow again. For this kind of question, it's better to bring all this, the worth at the present. Then after that we are gonna make it in just one present value. Then we can distribute as uniformly annual cash flow. Okay, let's do this one. We know that the first one, like when we calculate the present worth of any cost, let's say this is cost, and the first one is 45 multiplied by this is the future, the first year value, so we are gonna be P over F because it's future value. This 45 is future value. Again, this one is, let's consider as 7%, and then 1 year, right? The second year is plus, is gonna be 90 P over F, 7%, 2 years. Then the third year we are gonna make it plus 180 P over F, 7%, 3 years. Then we are gonna make it plus is 135 P over F, 7%, fourth year, plus 225 P over F, 7 for 5 years. And we can we can make it this, we can calculate it, this present worth cost, present worth cost as it was 45 multiplied by P over F 71, which is in the table. P over F for the first year is 0.9346, 0.9346, 46, plus the second year is 90 multiplied by the second year is 0.8734, 0.8734 plus 180, the third year is 0.8163, 0.8163 plus 135, the fourth year 0.7629, 7629 plus we are gonna have the last one 225 multiplied by 0.71 30. So we can calculate the present worth of cost after you multiply and then add each other. We are gonna find 531 is around like $531 worth of present worth of money we need to pay at the beginning of the maintenance cost, like, so we can cover all this ununiformly distributed. But what about, like, if we want to make it in an annual series? What we need to do, again, we know that this present value we need to multiply by the A over P, and we know that I and N. and A is equal to 531. I don't want to pay right now 531, so I said like make it distributed A over P, which is I is 7% again, and N it was 5 years, and it's gonna be 531 in the table. When I look at it, A over P for the 5 years 0.2439, which gives us 100, it's around $130. If I pay annually, it is gonna cover all 5 years. Instead of first year I am gonna pay 45, second year I am gonna pay 19, 130, 135, 225. I am gonna pay it every year 130, 130, 130, 130, and 130, and I'm gonna cover all this maintenance and repair cost. This question is ending here. Question is, if we change the previous questions sequence 3 to 4 years, so it was 180 before, and like $180 for the third year, and then 135 year in the fourth year. So we change it. When we change it, we see that there is a sequence is uniformly distributed. When it's uniformly distributed, we can say, okay, if we draw a line for the 45, and this above is gonna increase 45, then after that 90, then after that 135, and 180. So our G is arithmetically gradient, so G is gonna be 45, right? And our A, this line A is also $45. What we are gonna find again, we are gonna find annual cash flow calculation. Then we know that A is as we know that A0, which is the beginning, plus we are gonna make it like analysis, the equivalent annual cash flow. So we need this A0 plus we are gonna convert this G into the A value. As we know that the first year we pass by because it's annual series, then the second year the G is starting, which is we don't need to do anything right now. And we are gonna say A0, we are gonna calculate it with the table, so it's gonna be sorry, we are gonna here G, sorry, here, because we are gonna convert it to A, so it's gonna be A over G, I, which is again 7%, and N is gonna be 5 years. When we look at up, is gonna be 45 multiplied plus 45 multiplied by A over G 7% I in the table. A over G for the 5 is gonna be 1.865. 1.865 we need to multiply, and the answer is A is 45 plus 45 multiplied by 1.8565, it is $129. $129. So instead of this sequence, we can just pay $129. And what is the difference? Previous question, it was just changing this sequence. We were paying 130. Right now, when we change the sequence, we are gonna start to pay $129 for each year.
If you go through the annual cash flow analysis, we have again a situation and criterion. We know that the first one is neither input nor output fixed, so it's gonna be free input and free output, which is typical situation. And criterion is maximize the equivalent uniform annual worth, so which is the equivalent uniform annual benefit minus equilibrium uniform annual cost is going to be equal to equilibrium uniform annual worth. So we need to maximize it. And if we have the fixed input, which is amount of money or other input resources are fixed, we need to maximize the equilibrium uniform annual benefit. And if we have fixed output, we need to minimize equivalent uniform annual cost, because we have fixed task, so we need to minimize the cost. Okay, we can jump again the questions to analyze the problems of annual cash flow analysis.
Now we are gonna see how we are gonna analyze if we have two different options, device A and device B. In this question, in device A, we are paying $1,000 at the beginning. Then when we pay $1,000, or let's say there's a manufacturer or machine we bought for $1,000, then every year for 5 years, it brings $300. In the option B, in device B, we buy first, we pay 1,350, and it's paying annually uniform series of 300, but gradually increasing, arithmetically gradually increasing $50 each year. We are gonna analyze each segment, and we are gonna find which one is better options. So we need to have this concept, equivalent uniform analysis worth A. So we need to write it these terms, okay, in order to find the which options is better, or which analysis we are doing. So the other one is what it was, present worth analysis. This one equivalent uniform analysis, worth analysis. So I am gonna choose A right now at the beginning. It is $1,000 we are paying at the beginning. So $1,000, then we are gonna convert this one A over P, again 7%, right? 7% for the 5 years. 5 years. So this is the first equation we need to write here. If we take this one positive, we need to take the other stuff as negative. If we take this one as negative, then we are going to take it positive, the other one. It's better to use this one is negative. For my sake, I choose this way. You guys can choose the other way around. And we are gonna edit here, because we are using annual series. We just edit 300 here as plus, okay, because we divided into minus term in the annual series. So if we take this equation, it's gonna be minus 1,000 multiplied by A over P 7, and A over P 7%, 0.2439, 0.2439 plus 300. As it is seen here, 243.9 in the minus side, 300. So it's gonna be 56 points. It's gonna be positive. So we are earning. It shows that in 5 years we start to earn $56.1 each year. In second option, E U A W B. So it was 1350 is minus side, minus 1350, which is A over P, right? And 7%, and for 5 years again, plus in our equation 300 is the annual series, so we just add 300. Then we know that our G is 50 for each year, so 50, we need to make it A over G 7% for 5 years again. So let's make it disappear all these table terms. So minus 1350 multiplied by A over P, 7%, for 5 years is A over P 0.2439 again, 0.2439 plus 300 plus 50 multiplied by A over G for 5 years, 1.865. Okay. So at the end, when we calculate it, this is gonna be brings us $64, $64.0. If you compare which brings more is 64 this one and 56 this one, so I will choose option B, because even though I pay $1,350 at the beginning, it brings me more income instead of A, because A is bringing $56.1, B is bringing $60 per year. For like this is analysis, as this is plus like benefit, not like these numbers. This benefit, we are gonna get benefit from these options. This question is at here. In this analysis, we have 3 different options. It is plan B, and plan A, plan B, and plan C. And we have different materials, like the options that the first one is installed cost of equipment, which is we are gonna spend, so it's gonna be cost, so it's gonna be minus. Then material and labor savings per year, which is saving, so it's gonna make us earn benefit from this option, so it's gonna be positive, this one. And annual operating expenses, it's expense, so it's operating expenses we are gonna spend, is gonna be minus again. And end of useful life salvage value is like when the equipment is done, we are gonna sell it for the salvage, which is useless materials, so it's gonna be again, for in our case, is gonna be positive. So we can divide it into minus cost and positive as benefit, and we can divide it into the tables. So let's define our equivalent uniform annual benefit. So when I said benefit is gonna be, again, I said salvage value and then this material labor savings per year. So how we are gonna calculate it, this guy? Let's make it first. How many years we are talking about? We are talking about 10 years and 8% interest rate. So let me change it to my table for the 8 and for 10 years. Let's convert it first. This as useful salvage values and installed cost equipment, which is present value, and per year is annual operating expenses AA. So this is P, this guy is P, this is F. So we are gonna make it as an annual series. For this present value of 15, right, we are gonna convert it to A over P, 8% for 10 years. So we need to change it, this 15,000, 25,000 and 33,000 into the annual series. For 15,000, if we apply 15k, A over P, 8% and 10 years, A over P, 8%, 10 years is 0.1490, 0.19, sorry, 0. A over P for 10 years, 1490, yes. So 15,000, we need to multiply 0.1490, 25 with this one, that one. Okay, let's construct our table again. So it's gonna be installed cost for plan A, B, and C. Let's do this one. Instead of 15,000, is gonna be 2,235. 2,235. Instead of 25,000, is gonna be annual series of 3,725. 3,725. And instead of C, is gonna be 4,917. Okay. So this is initial cost. Then the other cost is annual operating expensive, which is 8,000, right? 6,000 and again 6,000. Okay. So if we say equivalent uniform annual cost is gonna be for A, B, and C is total of 10,235. This one is 10,235. For B is gonna be 9,725, and C is gonna be 10,917. 10,917. So this is equivalent annual cost. For benefit, we have material and labor savings per year, so it's gonna be A, so it doesn't matter. And end of useful life salvage value, we need to convert this one. A is equal to F because it's in the future. Then we are gonna convert it A over F, 8% for 10 years. Let's define it another page. So material savings, so let's make it here, material savings A, B, C. For material savings is gonna be 14,000, 15,000, no, 14,000, 9,000, 14,000, okay. 9,000 and 14,000. And if we look at this A over F, 8% and 10, which is A over F, where is, okay, 0.0690, 0.0690. We need to multiply it by our end of useful life salvage value. 1500 multiplied by 0.0690, it's gonna be 104 for this is salvage value. Let's say salvage value 104 for the A, 172 for B, and 228 for C. So if we take equivalent uniform annual benefit, is gonna be for A is gonna be total of 14,104, for B 1,172, and C is gonna be 14,228. For equivalent uniform annual worth is gonna be equivalent uniform annual benefit minus equivalent uniform annual cost. What we are gonna do is gonna be, again, for ABC, equivalent uniform annual worth for A, B, and C. We are gonna subtract the benefit from the cost, so we will have 14,104 minus 10,235 is gonna be $3,869 for A. Then after that, $553 for B, and for C is gonna be 3,313 is gonna be the C. So when we look at it, benefit minus cost, so the highest is A. So when we look at these three options, we are gonna choose plan A because it's benefiting us more in this question. We are gonna analyze if we have different useful life of different materials. In this question is pump A and pump B has different useful life. The first one has 12 years, the second one is 6 years, and we have the different salvage values after when they finish their useful life. We have a special formula for this annual cash flow analysis in different life sectors sections. Equivalent uniform annual, let's say, cost is equal to P minus S, which is present, minus salvage value, A over P, and I and N, and plus salvage value we need to multiply by I, which is the interest rate. Let's say we have again 7% for this kind of question. These questions is 7% interest rate. Let's solve these questions accordingly. If we have for the pump A is equivalent uniform annual cash diagram analysis for A is 7,000 minus 1,500, and we are gonna multiply it by A over P, 7% for 12 years, right? And plus we are gonna put 1,500 salvage value, we multiply by I, which is our 7%, which is 0.07, right? If we write it down again, equivalent uniform annual cost for A, so it's gonna be 7,000 minus 1,500 is gonna be 5,500, and multiply by A over P, 7% A over P, where is it, for 10 years, 0.1424, 0.1424, plus 1,500, which is salvage value, multiplied by 0.07, and total of is gonna be $797. For equivalent uniform annual cost for B is gonna be the same. Analysis is gonna be 5,000 minus 1,000 is gonna be 4,000, multiplied by, again, this time A over P, 7%, N is gonna be not 12 right now, 6, A over P, 7% for 6, plus 1,000 multiplied by 0.07. So 4,000 multiplied by A over P, 7, oh sorry, this guy is gonna be, I wrote it wrong. So A over P, 0.1259. This guy is gonna be 0.2098 plus 1000, 0.07 is gonna be plus 70, is gonna be, this guy is $909. So when we compare both of them, okay, one of them is $909, the other one is $797, which is cost for the both of them. Which one we are gonna choose? We are gonna choose less cost, which is pump A is gonna be better for us, and we are gonna choose pump A in this according to this analysis.
Okay, in order to calculate annual cash flow and make the analysis for the periods, we have different options as like the present worth analysis. We have analysis period equal to alternative lives, which is like we have like two of them is like maybe like 10 years old, 10 years useful lives, and the other one is analysis period a common multiple of alternatives. As you remember, we have like 7 and we have 13 years of useful lives of different alternatives, which is the common of 91 years, and which is analysis, and another one analysis period for continuing requirements, like we will have the under assumption of identical replacement economic studies based on alternatives own lives. When we go through the other one, like as you remember the infinite analysis period, we have we are gonna use again the principal amount, and then we will do with these alternatives on lives, and some other analysis period which is like need to estimate the terminal value, which we will put assign like 10 years, 20 years, whatever the project is, we will put the terminal values, and then we will start to make the our own analysis.
What if we have different again useful life, but is not in sequences like 12.6, let's say 12.9, and the salvage value again 1,500, 1,000, 7,000 initial cost for pump A, and then 5,000 pump B. It's the same question, but instead of 12.6 we are gonna have 12.9. It's gonna be the same thing basically. We just need to use our simple formula again, which is equivalent uniform annual cost for A is gonna be again 7,000 to minus 1,000, 5,000 is gonna be 5,500, and multiply by A over P, 7% for 12 years, which is A over P, 12 years, 0.1259 as before question, previous question, right? Then plus we are gonna add 1500, which is I is gonna be 7%, 0.07. Okay, so it's gonna be the same thing, $797 for equivalent uniform annual cost. For B, it's just gonna change a little bit. It's gonna be 5,000 minus 1,000 is gonna be 4,000. This time A over P, 7%, 9 years. We are gonna change from 6 years to 9 years. Only thing is change here is the coefficient is gonna change 0.15 and 35. Again, plus 1,000. This is 4,000. 1,000 multiplied by 0.07, and the equation. This equation is gonna give $684. So when we compare, this is 797 for pump A, and pump B is 684. The cost of B right now is decreased for the 9 years of useful life. So we are gonna choose right now. From 6 to it increased to 9 years, and right now pump B is gonna be better option in this case. What if we have the infinite analysis period? As we saw it in the first 4 weeks, we have if we have permanent structures like tunnels, roads, or like I don't know, highways, dams, such things is considered as permanent, and we have a formula for this one is A is equal to P multiplied by I, or we were having the different version, which is A is equal to P over I, right? In this question right now, this equivalent uniform annual cost, we can directly use PI for the first tunnel, and the first initial cost is 5.5 million. I is, in this question again, we can put let's say 6% right now. If we take 6%, it's gonna be 0.06. If it is 0.06, 5.5 million multiplied by 0.06 is gonna be $330,000, which is annually cost for the government if they want to make a tunnel, and if they want to pay yearly to the a company, is gonna be 330,000 instead of paying $5.5 million. In the pipeline, if the government made pipeline, we are gonna change it because it's 50 years. So equivalent uniform annual cost for the pipeline is gonna be how much is gonna paid is gonna be 5 million for the 50 years, 5 million for the 50 years. So it's gonna be A over P. I is 6% for 50 years. Let's check our table. 6% for A over P. A over P for 50 years. The coefficient is 0.0634. 5 million multiplied by 0.0634. So it's around $317,000. Okay, it's almost like as previous lecture I mentioned about it, when it is like 50 years or so forth is considered as like permanent. As you see, when it's 5.5 million initial cost is takes like $330,000, but when you make it 5 million is gonna be for 50 years is gonna be 317,000 annually. That means when even though like 6% of interest rate with this minimum interest rate is gonna be almost similar for 50 years and permanent agreement. And this question is done here. In this example, the analysis period is changing for alternative 1 and alternative 2 for 7 years and 13 years, which is not coming into account in the initial years. So, and also there is a terminal value of 10 years. For this kind of questions, if you use previous examples formula like salvage value, the present value minus future value, then after that we are going to add the whatever we salvage multiply by the interest rate is not going to work because it has different useful life, and we are gonna end it up in 10 years. We have a due date. It's better to use the present worth analysis. Then after that we are gonna convert it to annual equivalent uniform annual cost. So let's divide it again. In initial cost, if it is going to be minus, estimated salvage value, we are going to sell it at plus, and estimated market value after 10 years is going to be again plus. Let's make it in the net present worth for the first option, alternative 1. So it's going to be, at the present, is going to be buying for 50,000, so it's gonna be minus 50,000. Then after that, in 7 years, after 7 years, we are gonna let's say plus, we are gonna add it, right? So we are gonna let me do this one. We are gonna sell it for 10,000. We are gonna sell it for 10,000. So this is future value. So present to future, we are gonna bring it to present, and again, let's say this one 8% interest, 8% for 7 years. And then we are gonna buy again 50,000. Again, we need to buy it, and present future 8% 7 years. At the end of 10 years, we are gonna sell it, so it's gonna be again plus 20,000 present to future 8% for 10 years right now. So let's go through the other page. So net present worth of the first one is gonna be minus 50,000. So this both of them is mutual, so it's gonna be plus and minus. So it's gonna be plus and minus, so it's gonna be minus 40,000, let's say. And let's say this one minus 40,000, and A over P, let me see, P over F 8%. Let's see, 8%, P over F and 7 years is gonna be 0.5835. So let's go to the other one, 0.5835. Okay, it's gonna be minus again, I said, and plus 20,000 multiplied by P over F for 10,000, which is 0.46.32. When we edit each other, we are gonna end up as 64,076 is gonna be minus 64,076 dollars is net present worth of the first alternative. But we need to convert it to the equivalent uniform annual cost of first, which is gonna be net present worth of first. Then we are gonna convert it A over P. Present worth of 1 is gonna be net present worth of 1, so it's present worth, so we are gonna A over P 8% for how many years? 10 years. Terminal value is 10 years, so it's gonna be 64,076 multiplied by A over P for 10 years, 0.1490. So our equivalent uniform annual cost for 1 is gonna be 9,547 minus $9,547. So every year is gonna be paid for 10 years is gonna be 9,447 instead of paying 50,000 first, then after the selling for after 7 years, and then after that buying again another one and then selling in after 10 years. Let's make it the second analysis, net present worth, the second one. We just need to buy 75,000 at the beginning, and we see that there's the useful life of 13 years, so it's not gonna pass by. Then so we are not gonna sell, and we are just gonna sell it after 10 years for 15,000. So it's gonna be plus 15,000 multiplied by P over F, 8% for 10 years. Or when we made the, it's gonna be 75,000 plus 15,000. Let's see, P over F for 10 years is gonna be 0.4632. So when we add each other, net present worth of second one is gonna be minus 68,052. And if we convert it to equivalent uniform annual cost 2, again we are gonna be net present worth of 2. Then we need to multiply P over F, sorry, A over P for 8% for 10 years. Then it's gonna be 68,052 multiplied by, again, the same coefficient as here, which is 0.1459, 0.1459, and minus, so it's gonna be minus 10,142. So when we compare both cost, 10,000 is costly than 9,547. So we are gonna choose alternative 1 because we are gonna decrease our cost in order to our benefit. this question, and this unit is done here.